Hello guys, so today we are here to solve our daily Leetcode challenge for the day. This challenge is count number of maximum bitwise-OR subsets. Okay, so as soon as we hear bitwise and all these things, we tend to conjure up that this is going to be a very difficult problem. But I want to assure you one and all, that why fear when I am here? Yes. Why fear lead code when I am here? Because I would actually demonstrate it to you that this problem is not that difficult. This problem is very, very easy. And you may think that I'm bluffing, but let me, show some of the things about this problem, which even after getting to know those things, you yourself will say that this problem is actually easy. Not believing me, let me go ahead and start digging into the problem, and I'll unbear the facts. I'll bring out the facts. Okay, I'll unearth those things which will make you realize that this thing is actually easy. So let's jump into it, let's dig into it. Okay, so see, this problem is telling count number of maximum bitwise OR subsets. Okay, so what it is asking, count, it's asking count number of maximum bitwise OR subsets. Okay, so number of maximum bitwise OR subsets. Okay, it looks very difficult, but now let's get into the problem statement. So the problem statement is telling, given an integer array nums. Okay, so integer array nums is an integer array. Find the maximum possible bitwise OR of a subset of nums. Maximum possible bitwise OR of a subset of nums, and return the number of different non-empty subsets with the maximum bitwise OR. So number of different non-empty subsets. Number of different non-empty subsets. Remember, to generate the subsets we use backtracking. Okay, and it is asking return the number of non-empty subsets. So we have to enumerate the subsets and then figure out which of these subsets satisfy the criteria that they have the maximum bitwise OR. Okay, an array A is a subset of an array B. An array A is a subset of an array B if it can be obtained from B by deleting some or possibly zero elements. Two subsets are considered different if the indices of the chosen elements are different. Perfect, it makes sense. I mean to say, subset, we all know what is the concept of subset through set theory. Okay, a set is a subset of another set. Okay, if that thus if the set contains some or all of the elements of the other set. So let's say A is one set and B is another set. A is subset of B if A is contained in B, or B contains A is contained in B. So B contains all of the elements of B in addition to some of the other elements. Okay, and it's need not be containing other elements. It can contain just A, then also A is subset of B. Okay, so now the other thing is that a bitwise OR of an array is equal to A0 OR A1 OR. So see, we are doing OR. So OR, how OR is defined, bitwise OR. So see, if you do 0 or 0, then the result is 0. If you do 1 or 0, then the result is 1. If you do 0 or 1, then also the result is 1. If you do 1 or 1, then also the result is 1. So only when two zeros are getting odd, then the result is 0. Otherwise, if there is even single one anywhere, either in the left side or on the right side, the result of that will be 1. Okay, and we need to consider this. I mean to say, we need to understand this. And if we are understanding this, then how are we going to solve this? So let's start once more. Okay, so first of all, we need to tell what is the maximum bitwise OR. So we will declare one max OR. Okay, and we'll start it with 0. Okay, and then we'll loop over all of the elements of the nums array, and then what we'll do, max OR, this is a variable name, and then it will be like this. So this is the max of all this element is stored in this. Now we need to check which different subsets of the maximum bitwise OR is having that. this max R value. So obviously what we can do that, we can generate all the subsets of it. So to generate all the subsets of it, we'll have to do list of integer, this is results, is equal to result list, let's say result list, and then we'll make it as array list. Okay, and then we'll take one list of integer, and this will be partial list is equal to new array list. Okay, and then we'll do backtrack. Okay, and in backtrack we'll pass the nums. Okay, the start of this is 0, and max R will pass because we want to check. Okay, if we want we can pass the length of the array. So let's take the length of the array here itself. Int n is equal to nums dot length. Okay, so we can pass this as here. Okay, max R, and then we want to pass the partial list. So partial list will be that partial subset will be generated and kept, the elements will be kept in this partial list, and here is the result list. Okay, and when we do this, so after doing this will be the result list will be populated, and what we'll be doing that we'll be checking for list of integer of list of result list like this, and then we will do one check, if check of list, check max R of the given list is equal to max R. Okay, then we will increment our count, and we have not declared the count, so let's declare the count also here. So count is equal to 0. Okay, and at the end we can just return the count. Okay, so see, so we are trying to generate all the subsets and check element by element by doing the OR of this. So how are we going to check it? So to check the OR of it, what we will do that we'll do return the end check max OR. Okay, and then it will be list of integer, and it will be list, and again we will declare one OR is equal to 0 for int I of the list, and we'll do OR of I, and at the end we'll be returning this OR. Okay, and we'll be doing this. But now the thing is that we need to complete this backtrack method. So since backtrack is not returning anything, we have to just write backtrack, and then what we have to do, we have to pass this array nums is an array, and then is the start index, and then int length. Okay, length is the nums length, that is not a big deal, but we are taking it. Okay, and then we have to take one list of integer, and it will be partial list. Okay, and then list of integer, and this will be result. Okay, like this. So we can take this this side. Okay, and now so let me concentrate, the logic of this is very important. So if we try to go through this, then so see what we will do here, that we will do if the if this start is equal to length. Okay, and if so we have to do one current jar also. So in this we have to pass one other variable called current ZOR. Okay, and in here we have to take max ZOR and start and max R and end uh, car. Okay, so car will be current R. Okay, so now this is clear to us. If COR is equal to max OR, then we'll be incrementing this count. Otherwise, if it is not, then in that case also we'll be returning. Okay, and otherwise, see what we'll do here. So this is the backtrack. The gist of the backtrack here is happening in these two lines. What is happening here? Start, we are taking the start plus 1 we are doing. Okay, length will be the same. Okay, max R also will be the same. Okay, current R will be the ZOR of the nums of start. Okay, and oh no, we don't want to do that. Yeah, we are not, we just want to generate the subsets. Sorry. Okay, so we don't want to take care of this current ZOR and max ZOR. We just want to generate the subsets. To generate the subsets, what we need to do? We need to, to generate the subsets, what we need to do? So we will be taking this, and then start is equal to length, and then so we have completed this partial list is completed. So we'll be doing result dot add of new result dot add new array list. Why we are doing new array list? Because we want to have a clone of this partial list. This reference will be, if you see, so this is void, so we have to return just, we have to return, okay, like this. Okay, and then so this is not required as of now, because we are doing this after the length and partial list dot add nums of start. So this line we should be taking it outside this. Okay, because this is going to return some boolean value. So partial list dot add, and then we'll be calling the backtrack, and on calling the backtrack will be, on calling the backtrack we'll be passing this partial list and then this result. So why we are not doing this? Because this call will be returning some boolean value. Okay, so we don't want boolean value to be passed. We want the actual partial list to be passed. And then here what we will do, partial list dot remove. Okay, partial list dot size -1. So last, what is the element that was added last? We want to return it back. And otherwise, the thing is that we have to skip that element. To skip that element, we will be, again incrementing this start. The length will be the same. Partial list, that element will not be added to the partial list. Okay, and result also will be passed as it is, because result, we are not changing the the result at all. So if we do this and run this, okay, so see what we have done. Let me briefly go through the steps of these things what we have done. So we have taken the length n as the length of the given nums array, count is 0, max r is one variable, and then what we are doing, we are manually we are going through the content of the nums array and checking what is its nums are. And by doing this, what is what is that we are getting? See, the basic property, as I mentioned, for R is that even if there is one at any position. If there is 1 1, then the result will be 1. Okay, either it could be 0 or 1, 1 or 0, or 1 or 1. In all these three cases the result will be 1 only. Okay, in all these three cases the result will be 1 only. Okay, now list of integer is the result list of integer is the partial list. Okay, and now we are declaring these two things. A result list will be containing all the subsets of the given nums array, and partial list will be, is what we are keeping the, when we are generating the list, the, the subsets which is under construction, that is we are keeping in the partial list. Okay, and then we are calling this backtrack method is giving us all the, you know different subsets of the nums array, inside the result list. It is contained inside the result list, and then we are, going through the different lists in the result list, and again we are calling check max or, and this check max or is, one by one it's going through the element and finding the or of it, and it's returning what is the value of it. So if it is equal to max or, then we are incrementing that count, and finally we are returning the count. So this is, step by step execution of what is, given in this problem. And let's run this and see this, whether this is working fine or not. So as I see, I think it is working fine only. I don't see any error. Let me just press the run button. Perfect. Perfect. And see how long, how time taking this solution is. It is one of the slowest solution. How to expedite this? So can we expedite this? I think we can expedite this. Okay, so what can we do to expedite this? I think, uh, see, definitely we have to go through the list, but instead of generating all the subsets and then returning them and then going through the subsets one by one, so it is kind of, overkill. What we can do here is that we can, just do all these things in a, in a single shot. And how are we going to do that? So see, the basic idea is this only, but this basic idea will be optimized. Okay, so we are going to build on optimizing this basic idea, and we are going to create a very suave solution. Okay, and that solution is going to be very very very, uh, I can say, as per my understanding, it is going to be an efficient solution, and I hope you also like those solutions. Okay, so let me start with the process of optimization of this solution. So to optimize this, see, we are passing many things in this backtrack call. So it's better to keep them as a global variable and not, pass them as a, you know, backtrack thing. Okay, so private int n is equal to, initially it's 0, and then we can say that this dot n is equal to nums dot length. Count also we need not pass through each of the, calls. So this also let it be 0, and here also we can say this dot count. Maxr is also, we can declare it here only. Private int maxr is equal to 0, and again here we can declare this as this dot maxr. So okay, like this, and then we are doing this, and then list. So see, here we are generating the subsets, but I don't want to do that. Okay, so instead of generating the subsets, what we want, that, we want the count of the subsets. So which, this part is, we are generating, that is not required. So what we can do here, that, we'll pass the start. Okay, and then we can pass, start count is there, n is there. Okay, and okay, so this thing is separately not required, we can remove this. Okay, and return count is required, so we can return, and we'll say return this dot count. And since this thing is not required, so we can get rid of this thing. And in backtrack we are only passing nums and start. Length is not required because length is the global variable. Parcel list is not required. Result also is not required because we are not generating the subset of the nums array. Okay, and then what we are doing, if start is equal to n, it's better we use this n. Okay, this dot n. Okay, and then here we are not doing this. So what we are doing here, instead of this, if this is there, and then so we can do one more or here, and this or will be current zar. Okay, and we can check if current zar is equal to max zar, max r, not current jar, yeah, it's max current r. Okay, all the time I do this mistake. So current r is equal to max r. If this is the case, then what we will do, we will if current r is equal to max r, then we'll be incrementing the count, incrementing this dot count, and closing it here. Otherwise we'll just return. Okay, and once we are done with this, we don't need partial list because we are not populating the partial list and the final result list, so this step is not required. Now what is required, definitely start plus 1 will be done, and then we are maintaining this current zar. So current zar will be current r. Every time I'm making this mistake, please forgive me. So nums of the current element is start, and then we are going to the next index. Okay, so this start plus 1 is going to the next index, but the current element has to be ORed with the current r, so that we get the new current r. Okay, and this is one thing, and the other thing is that when we are done, we are not we are skipping the r operation for the current element. So these are the two things, and let's see whether the solution works or not in this case. Okay, perfect. Perfect. So see, this is working fine. Okay, but I can give you a guarantee that even we can optimize this still further. And how can we do that? Let me explain it to you. Okay, let me explain it to you. See, the beauty of R, time and time again I'm repeating that R is one only when either one of the operand is 1. Okay, if both are 0, then only the r will be 0. Otherwise, if either of them is 0 or both of them are either of them is 1 or both of them is 1, the r operation result will be 1 only. Okay, so this you have to be keeping in mind. So it means that as soon as one bit becomes 1, one r bit becomes 1, then there is no way on earth that it can go back to 0 value, because if either if that bit is 1, and for the other operand bit, even if it is 0 or 1, it doesn't matter, the result will be always be 1 only. Okay, so as soon as one bit is set in the or operation, in the series of or operations, that bit will be retaining its value all along. Okay, so to keeping this in mind, we have to if you want to add one more optimization to this, so what we can do, that if current r is equal to max r, okay, then we will do this dot count is equal to count plus is equal to math dot power of 2, and then this dot n minus start. Okay, like this. but math.power will be returning a double value which we need to cast it back to the int. Okay, and if this is the case, then we are just returning it because in any way we have countered this. Okay, so let me run it once more. This is wrong. Math dot power of 2 this of n minus start. Why it should be giving 0 answer? Oh, we have to put the return here. Okay, this, and then here we have to do return. Okay, and we can put one else if like this also here. Okay, perfect. So see, this has become more efficient. Can we make it, optimize it even further? See, this power of 2 is little time taking, and we know a better way to handle this. What is that? So the better way to handle this is not let not let not let let's not call this method at all. Okay, and what we are going to do, one like this. Okay, okay, let's see what is the result of this. Perfect. So this is also like this. I guess if we run it other times, then it will be reaching 0. Okay, okay, can you do any other things than this? So why we are doing this? We are doing this because once current OR becomes max OR and we have not reached the end of the nums array, then it means that that even if we do OR even further after reaching the max OR value, current OR value has already reached the max OR value, and if we continue to do on OR operation with the remaining elements, all those elements will be not be decrementing the R value, because as and when the R value reaches some maximum value, it cannot go down. Okay, even if you R it with 0 or 1, if that bit is set in the R operand, or due to the result of that R operation, if some bit is set, it cannot be unset. Okay, this is the very vital thing about this problem. And since it cannot be unset, whatever remaining is there, all those subsets of including those things are going to be incrementing the count value only. So this count is getting incremented here, and if we keep this in mind, our solution is able to prune this, and this is very vital thing about this problem. Let me run this once more. Okay, okay, so I think we are done with this. If there is any other problem, let me know. I'll definitely try to answer those doubts. So with this, I'm thanking you one and all. Happy coding, best wishes. I hope you like this solution. I really enjoyed doing this problem. Thanks a lot. Best wishes.